Write 36 as a product of its prime factors. So as you can see, this question is worth 2 marks. So your first mark comes from using a suitable method to find the prime factors, and then your second mark comes from getting the correct answer. So one method you could use to find the prime factors is a factor tree. So we start off with the number 36 at the top, and then we want to find 2 numbers which will multiply together to make 36. We can divide 36 by 2, so we can do 2 and then 18. Now 2 is a prime number because we can only divide it by itself and 1. So we can circle this to make it clear that we can't divide this anymore. Now again we want to find 2 numbers which will multiply together to make 18. So we can again divide 18 by 2, and 2 is a prime number, so we can circle this. And 2 multiplied by 9 gives us 18. Now we can still divide 9 further, and we can divide 9 into 3 and 3. And 3 is another prime number, so we can circle these. So this tells us that our 4 prime numbers, which make up 36, is 2 multiplied by 2 multiplied by 3 multiplied by 3. And this is where your final mark comes from, by writing the correct answer. Kyria is 7 years older than Jay. Martha is twice as old as Kyria. The sum of their 3 ages is 77. Find the ratio of Jay's age to Kyria's age to Martha's age. So we can solve this question algebraically. And to do this, we can let x be equal to Jay's age. So now what we can do is we can display each of these 3 people's ages in terms of x. So if we start off with Jay, Jay's age is x. Now if we take a look back at this question, Kyria is 7 years older than Jay. So if Jay is x years old, Kyria will be x plus 7 years old. Now Martha is twice as old as Kyria. So that means Martha will be 2 times by x plus 7 years old. And if we multiply out these brackets, we get 2x plus 14 years old. This is where your first mark will come from. Next, we can see from the question that the sum of their 3 ages is 77. Now their 3 ages are x, x plus 7 and 2x plus 14. So we can write out that x plus 7 plus 2x plus 14 equals 77. And we can again simplify this down. So first start off with the algebraic terms. So we have x plus 2x, which gives us 4x. And then the numeric terms. So we have 7 and then we have 14. So this gives us 21 equal to 77. So this is where your second mark comes from. However, in order to work out what x is, we need to rearrange this equation here. So what we can do is we can minus 21 from both sides. So we'll get 4x is equal to 56. Now in order to get x on its own on one side, we can divide both sides by 4. This gives us x equals 14. So working out what x is equal to is where your third mark comes from, and the thing we need to do for the final mark is work out the ratio. So we want to work out the ratio of Jay's age to Kyria's age to Martha's age. Now what we worked out at the start of this question is that Jay's age is equal to x, Kyria's age is equal to x plus 7, and then Martha's age is equal to 2x plus 14. So the final thing we need to do for this question is substitute in the value we found for x, which is 14, into this ratio here. So we get 14 to 14 plus 7 to 2 multiplied by 14 plus 14. Now if we simplify this down, we get 14 to 21, and then 2 multiplied by 14 is 28 plus 14, giving us 42. ABCD is a parallelogram. EDC is a straight line. F is the point on AD so that BFE is a straight line. Angle EFD is 35 degrees. Angle DCB is 75 degrees. Show that angle ABF is 70 degrees. Give a reason for each stage of your working. So as we can see from this question, we've been given a diagram. So we can start this question off by annotating this diagram. But it's really important to give a reason for each stage of your working. So the first thing we can start off with is this parallelogram ABCD, which is this one here. Now opposite angles in a parallelogram are equal. So this means that angle BAD, which is this angle here, is also 75 degrees. So we can write this down here. So we can write angle BAD is 75 degrees because opposite angles in a parallelogram are equal. Now if we take a look back at this diagram, we can also see that this angle here, AFB, will also be 35 because vertically opposite angles are equal. So we can also fill this in. So again, we can write this in the space below so it's clear where we've got our answer from. So we can write that angle AFD is 35 degrees because vertically opposite angles are equal. So now in our diagram we have enough information to complete this question. So the question is to show that angle ABF is 70 degrees. Now as we can see, we have a triangle here, which is triangle ABF. And we have two angles in this triangle. Now all angles in a triangle add up to 180 degrees, so we can work out what this angle here, ABF, will be equal to. So we want to work out 75 plus 35, which gives us 110, and then we want to minus this from 180. So 180 minus 110 is 70 degrees. So this therefore proves that angle ABF is 70 degrees. So the final thing to complete this question is to just write a summary statement. So we can write, therefore angle ABF is 70 degrees. And this is enough to get you your full marks because you've shown all your workings within the diagram and in this answer space here. The diagram shows a logo made from 3 circles. Each circle has a centre O. Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show all your working. So we've been given a diagram for this question, and we need to work out what the area of this shaded area here is. So we can start off by just labelling these circles A, B and C. Now the area of a circle can be worked out by pi r squared, where r is the radius. So if we start off by working out the area of each of these 3 circles, so we can start off with circle A. So the radius of this circle is 4 centimetres, as the distance from the centre to one edge of the circle is 4 centimetres. So we can substitute this into the formula. So the area is equal to pi times by 4 squared. And 4 squared is 16, so this gives us an area of 16 pi. Next we can take a look at circle B. So again we need to work out what the radius is. So we want to find the distance from the centre of the circle to one edge, which is 4 plus 3, which gives us 7. So the area of circle B is pi multiplied by 7 squared, which gives us 49 pi. Now finally the largest circle. The radius will be 4 plus 3 plus 3, which gives us 10. So the area for circle C is pi multiplied by 10 squared, which gives us 100 pi. So in order to work out this question, we need to divide the area of this shaded area here by the area of the total circle, so circle C. So in order to work out the area of this shaded area, we need to minus the area of the smaller circle from the area of the medium-sized circle. So the area of B minus A. So the shaded area is equal to 49 pi minus 16 pi, which gives us 33 pi. So what we need to do now is we need to divide the area of the shaded area by the area of the largest circle to work out how much of the circle is shaded. So the shaded area is 33 pi and the total area is 100 pi. So we can cancel out the pi, which leaves us with 33 over 100. Now Daisy says that exactly 1/3 of the logo is shaded. Now we've worked out that Daisy is not correct. So we need to write a final summary statement. So Daisy is not correct because 33 over 100 does not equal 1 over 3. The table shows information about the weekly earnings of 20 people who work in a shop. Work out an estimate for the mean of the weekly earnings. So in order to work out an estimate for the mean of the weekly earnings, we need to find the midpoint of their weekly earnings, which is this left-hand side column here. So what we can do is we can add an extra column to this table here. And we can write the midpoint in this column. So the midpoint of 150 and 250 is 200, and we'll carry this on for the rest of the table. So now what we need to do is we need to work out a mean for this information. So as we can see from the frequency column, one person has a weekly earning of 200. So we can do 1 multiplied by 200. And the next row down, 11 people have a weekly earning of 300. So we can add 11 times by 300. Next, 5 people have an earning of £400. So we'll do 5 multiplied by 400. 0 people have an earning of 500, so we can miss this one out. And then finally 3 people have a weekly earning of 600. So next we can simplify this down. So 1 multiplied by 200 is 200. Now 11 times by 300 might look difficult, but if we remove these two zeros and do 11 multiplied by 3, this gives us 33, and then we can add the two zeros on. 5 times by 400 gives us 2000, and then 3 multiplied by 600 gives us 1800. And next we need to add these all together. So we can use a column method for this. So as we can see, the first two numbers will be 0, as there's only zeros in those columns. 2 add 3 add 0 add 8 gives us 13, and we'll carry over the 1. And finally 3 add 2 add 1 gives us 7. So what we can see is that 200 add 3300 add 2000 add 1800 gives us 7300. Now 7,300 would be the total weekly earnings of all 20 people. So what we need to do to find the mean of these earnings is we need to divide 7,300 by 20. Now again, this might look like quite a difficult sum, but we can cancel out these two zeros on both the top and bottom of the fraction, and this leaves us with 730 divided by 2. So what we need to do is half 730. And this gives us a mean weekly earning of £365. Nadia says the mean may not be the best average to use to represent this information. Do you agree with Nadia? You must justify your answer. So as we can see from the table we were given in Part A, there were quite a few outliers, especially in this higher weekly earnings area. Now when we're using the mean, we must include these outliers in the information. Now including these higher weekly earnings will bring the average up, and it may not be an accurate representation. So Nadia says that the mean may not be the best average to use. And because the outliers will affect this information, we can agree with Nadia and say, yes, we agree with Nadia because outliers will affect the mean. Here is a rectangle. All measurements are in centimetres. The area of the rectangle is 48 centimetres squared. Show that y equals 3. So as you can see, we've been given a diagram with 3 out of 4 of the side lengths filled in. Now we can fill in this final side length by using the knowledge that opposite sides in a rectangle are equal in length. So as you can see, both of these two sides will be equal to y because one of them is. Now we can apply the same principle to these two sides, 2x plus 6 and 5x minus 9. And we can form an equation for this. So this tells us that 2x plus 6 is equal to 5x minus 9. Now this is where our first mark will come from. And in order to work out what x is equal to, we need to isolate the x term on one side by rearranging the equation. So to do this, we can minus 2x from both sides, which gives us 6 is equal to 3x minus 9, and then we can add 9 to both sides, which gives us 15 is equal to 3x. And finally, we can divide both sides by 3. And this tells us that x is equal to 5. Now by isolating this x term, we can get our second mark. So the next thing we can do is we can take a look back at this diagram. Now we've just worked out that x is equal to 5, so we can work out what these side lengths are equal to. So what we need to do is we need to substitute x equals 5 into these side lengths. Now we only really need to do one because both side lengths are equal. However, it's good practice to do both just to check that we've done our workings correctly. So if we start off with 2x plus 6, so 2, and then we'll substitute in the 5 plus 6. So we'll do our multiplications first, so 2 times by 5 gives us 10 plus 6, and 10 plus 6 is equal to 16. So we can write this in. Now we can check this with our other side length, so 5x minus 9, so 5 and then we'll substitute in the 5 and then minus 9. So 5 multiplied by 5 is 25, minus 9, again giving us 16. So we know that both of these side lengths are equal to 16. This is where our third mark comes from. Now in order to get our final mark, we need to show that y equals 3. Now we've been told that the area of the rectangle is 48 centimetres squared. Now the area of a rectangle is equal to the base multiplied by the height. So we've been told that the area of this rectangle is equal to 48 centimetres squared. And if we take a look back at the rectangle, we can see that the height is 16 and the base is y. So we can again fill this into the equation. So the base is equal to y and the height is 16. So what we need to do to get our final mark is divide both sides by 16, and 48 divided by 16 gives us 3, and y multiplied by 16 divided by 16 gives us y. And we've now proven that y is equal to 3. Brogan needs to draw the graph of y equals x squared plus 1. Here is her graph. Write down one thing that is wrong with Brogan's graph. Now if we take a look at Brogan's graph, we can see that Brogan has drawn her lines with a ruler. And we can see this because these lines are straight rather than curved. So one thing that is wrong with Brogan's graph. So Brogan has used a ruler to draw her curve when the line should have been drawn freehand. Now this is a 1 mark question, so we get our 1 mark from this explanation here. Write these numbers in order of size. Start with the smallest number. So as we can see, for this question we've been given 4 numbers. Now the best way to do this question is to rewrite these numbers but to more decimal places. So if we start off with the first number, the dots are above the 4 and the 6, which means we'll repeat the 4 and the 6. So the first number is equal to 0.24646 and so on. Now the second number, the dot is just above the 6, so we'll only repeat the 6. So this is equal to 0.24666 and so on. Now the third number, the dot is above the 2 and the 6, so we'll repeat all of these 3 numbers. So this is equal to 0.246246 and so on. And finally the last number is just 0.246, so we can write this as 0.24600. Now we can get one of the marks for rewriting these numbers to more decimal places. So as we can see, all 4 of these numbers start off with 0.246. So in order to put them into size order, we need to look at the 4th number after the decimal place. So we can underline this number. So we have a 4 for the first number, a 6 for the second number, a 2 for the third number and a 0 for the 4th number. And we can use these numbers to order these into size. So as we can see, the number underlined for the 4th number is a 0, which means we can put this first. We're now looking for the second smallest underlined number, which is this third number here. The third smallest underlined number is this third number here. And now the only remaining number is this second number here. And this is where our second mark will come from. James and Peter cycled along the same 50-kilometre route. James took 2.5 hours to cycle the 50 kilometres. Peter started to cycle 5 minutes after James started to cycle. Peter caught up with James when they had both cycled 15 kilometres. James and Peter both cycled at constant speeds. Work out Peter's speed. So the equation we'll need to use for this question is the one that relates distance, speed and time. Now we can write this out in a formula triangle. So your distance is equal to your speed multiplied by your time. So if we start off with James, so it took James 2.5 hours to cycle 50 kilometres. Now we want to work out what James's speed was. So what we can do is we can do our distance divided by our time. So the distance is 50 and the time is 2.5. Now we can rewrite this as 100 over 5, and 100 divided by 5 is 20, and this is in kilometres per hour. So the next piece of information we can see is that Peter started to cycle 5 minutes after James started to cycle, and Peter had caught up with James when they had both cycled 15 kilometres. So what we can do is we can work out how long it took James to cycle 15 kilometres. So what we can do is we can do 15 divided by 20, because our time is equal to distance divided by speed, and this gives us 3 over 4 hours, which is also equal to 45 minutes. So this tells us that it took James 45 minutes to cycle 15 kilometres. Now because Peter started to cycle 5 minutes after James, and he caught up with James after they both cycled 15 kilometres, we can work out that it took Peter 45 minus 5 minutes to cycle 15 kilometres. So that means it took him 40 minutes. Now 40 minutes is equal to 2/3 of an hour. And we now have all the information we need to work out what Peter's speed was. So in order to work out speed, we do distance divided by time. So our distance is 15 kilometres, and then our time is 2/3 of an hour. Now we can rewrite 15 as 15 over 1, divided by 2 over 3. And when we're dividing fractions, we keep the first fraction the same and we flip the second fraction. So this gives us 15 over 1 times by 3 over 2. And 15 times by 3 is 45, and 1 times by 2 is 2. So 45 divided by 2 gives us 22.5 kilometres per hour. Now this question is worth 5 marks. So the 5 marks come from working out what James's speed is, how long it took James to cycle 15 kilometres, how long it took Peter to cycle 15 kilometres, and then using a suitable method to work out what Peter's speed was. And then the final mark comes from getting the correct answer. Write down the value of 100 to the power of a half. So 100 to the power of a half is equal to the square root of 100. And the square root of 100 is 10. And this question is worth 1 mark, so we get the 1 mark for the answer. Find the value of 125 to the power of 2 over 3. So 125 to the power of 2 over 3 can be rewritten as 125 to the power of a third, all squared. Now this is because 1 over 3 multiplied by 2 gives us 2 over 3. Now if we start off with what's inside the brackets, 125 to the power of 1/3, well, we can rewrite this as the cubed root of 125, and again all squared. So the cube root of 125 is 5. And this is because 5 multiplied by 5 multiplied by 5 gives us 125. And then finally 5 squared is equal to 25. So this question is worth 2 marks. So we get our first mark for showing our workings and our second mark for the correct answer. 3 teas and 2 coffees have a total cost of £7.80. 5 teas and 4 coffees have a total cost of £14.20. Work out the cost of 1 tea and the cost of 1 coffee. So what we need to do for this question is we need to form 2 equations from these 2 statements. So in order to do this, we can let T be equal to T and let C be equal to coffee. Now the next thing we need to do is form an equation. So 3 teas and 2 coffees are equal to £7.80. So 3t plus 2c is equal to £7.80. And then 5 teas plus 4 coffees is equal to £14.20. Now this is where your first mark will come from. So the next thing we need to do is we need to eliminate one of these variables. Now in order to do this, we can form a set of simultaneous equations for these 2 equations here. However, in order to form simultaneous equations, we need one of these variables to have the same number in front of each other. So as we can see, we have a 2c in the first equation and a 4c in the second equation. So what we can do is we can multiply this first equation by 2 so that we'll get a 4c in the equation. So 3t plus 2c equals £7.80. Now if we multiply both sides by 2, so 3t times by 2 will give us 6t, 2c times by 2 will give us 4c, and £7.80 multiplied by 2 gives us £15.60. So if we label up this equation as equation 1 and this equation as equation 2, so in order to work out what 1t is equal to, we need to do equation 2 minus equation 1. So now what we need to do is work out what this is equal to. So 6t minus 5t is equal to t. 4c minus 4c is equal to 0. And then £15.60 minus £14.20 gives us £1.40. So this tells us that 1t is equal to £1.40. Now this is where your second mark will come from. So as we can see, we've worked out what one of the variables is equal to, but we've not worked out what the coffee is equal to. So we can substitute this t back into one of the original equations to work out what the coffee is equal to. So 3 multiplied by £1.40 plus 2c is equal to £7.80. So the first thing we can do is multiply out these brackets here. So 3 multiplied by £1.40, well 3 multiplied by 1 is 3, and 3 multiplied by 0.4 is 1.2. So this gives us £4.20 plus 2c gives us £7.80. So we can minus £4.20 from both sides. So this gives us 2c is equal to £3.60. And finally we can divide both sides by 2, which tells us that 1 coffee is equal to £1.80. So you get your third mark for substituting the price of the tea back into one of these original equations. And for the final mark, we need to write the answers into the answer box. So 1 tea is equal to £1.40 and 1 coffee is equal to £1.80. The table shows information about the heights in centimetres of a group of Year 11 girls. Draw a box plot for this information. Now, in order to draw a box plot, we need the lowest value, we need the lower quartile, we need the median, we need the upper quartile, and then we need the highest value. So as you can see in the table we've been given the lowest height. So we can write this in. We've been given the lower quartile, which is 161. The median is 165. And now we need to work out what the upper quartile is and what the highest value is. So if we start off with the upper quartile, we can work this out by using the lower quartile and the interquartile range. So if the interquartile range is 7 and the lower quartile is 161, then the upper quartile will be 161 plus 7 centimetres, which is 168. And we can get 1 mark for working out the upper quartile. Now, in order to work out what the highest value is, we can use the lowest height and the range. So the lowest height is 154 centimetres and the range is 20 centimetres, which means the highest height will be 154 plus 20 centimetres, which gives us 174 centimetres. So now what we need to do is we need to fill this into the box plot. So for a box plot, we draw a vertical line for the lowest value and the highest value. So if the lowest value is 154, we can draw a vertical line at 154 centimetres. And we can do the same for the highest value, which is 174 centimetres. The next thing we can fill in is the lower and upper quartile. So again, we'll draw a vertical line for the lower quartile and the upper quartile. So the lower quartile is 161 and the upper quartile is 168. And then for a box plot, we join these two lines here, and then we make the interquartile range into a box. So the final piece of information we need to fill in is the median, which is 165 centimetres, which again we'll draw a vertical line. And we get our final 2 marks for correctly filling in this box plot. The box plot below shows information about the heights in centimetres of a group of Year 7 girls. Compare the distribution of heights of the Year 7 girls with the distribution of heights of the Year 11 girls. Now, in order to compare these 2 box plots, we need to compare the median and we need to compare the interquartile range. So if we take a look at the box plot above, we can see that they both have the same scale on them. And what we can see is that Year 11 has a smaller interquartile range than the Year 7 students. And we can also see that the Year 11 students have a higher median than the Year 7 students. So we can write something like Year 11 have a higher median height than the Year 7 students, and Year 7 have a larger interquartile range than the Year 11s. And we get 1 mark for comparing the median height and 1 mark for comparing the interquartile range. A factory makes 450 pies every day. The pies are chicken pies or steak pies. Each day Milo takes a sample of 15 pies to check. The proportion of the pies in his sample that are chicken is the same as the proportion of the pies made that day that are chicken. On Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. Work out the total number of chicken pies that were made on Monday. So the first thing we can do for this question is highlight the key pieces of information. So the first thing is that the factory makes 450 pies a day. Milo takes a sample of 15 pies to check. And the proportion of pies in his sample that are chicken is the same as the proportion of pies made that day that are chicken. So as we can see, Milo calculated that he needed exactly 4 chicken pies in his sample. And his sample is made up of 15 pies, so this means that 4 out of the 15 pies will be chicken. So what we can do is we can make x equal the number of chicken pies. And from this we can work out that 4 over 15 is equal to x. And then if there's 450 pies made every day, then it will be x over 450. And we get one of our marks for writing this. And now the final thing we need to do is rearrange this equation to make x the subject and therefore work out the number of chicken pies. So in order to do this, we can multiply both sides by 450. And this will give us 4 multiplied by 450 divided by 15 is equal to x. And now what we need to do is work out what this is equal to. So x is equal to 4 multiplied by 450, which is 1,800, divided by 15, which we can simplify down to 360 over 3 by dividing both the top and bottom by 5, which tells us that x is equal to 120. So if x is the number of chicken pies, this means that 120 chicken pies were made on Monday. And this is where our second mark will come from. On Tuesday, the number of steak pies Milo needs in his sample is 6 correct to the nearest whole number. Milo takes at random a pie from the 450 pies made on Tuesday. Work out the lower bound of the probability that the pie is a steak pie. So the first thing we need to do for this question is work out what the lower bound of 6 is to the nearest whole number. So we want the smallest possible number, which will still round up to 6. So the lower bound is 5.5. So we can use the same method that we used in part A. So we can let y equal the number of steak pies. So if the lower bound is 5.5, this means that 5.5 pies out of 15 pies is equal to y divided by 450. And again, we want to rearrange this equation to make y the subject. So we can multiply both sides by 450. This gives us 5.5 times by 450 divided by 15 is equal to y. Now we can rewrite the left-hand side of this equation to make it easier to work out. And we can rewrite it as 5.5 multiplied by 450 divided by 15 is equal to y. And this 450 divided by 15 is easier to work out. And this gives us 5.5 times by 30 is equal to y. And then 5.5 times by 3 is 16.5, which means 5.5 times by 30 is 165. So this means that there's 165 steak pies made on Tuesday. However, we want to work out what the probability that the pie is a steak pie will be. So if there's 450 pies in total, then the probability will be 165 divided by 450. So this question is worth 2 marks. So we get the first mark for working out what the lower bound is, and we get the second mark for working out the probability. The ratio y plus x to y minus x is equivalent to k to 1. Show that y equals x brackets k plus 1 divided by k minus 1. So the fact that this ratio is equivalent to k to 1, this means that k to 1, if we multiply both sides by an unknown number, it gives us y plus x to y minus x. Now because of this means that k divided by 1 will be equal to y plus x divided by y minus x. And we'll get our first mark for writing this equation. Now what we need to do next is show what y is equal to. So we want to rearrange this equation to make y the subject. So k divided by 1 is equal to k. So the next thing we can do is we can get rid of this fraction on the right hand side of the equation by multiplying both sides by y minus x, which gives us k multiplied by y minus x is equal to y plus x. Next we can expand out these brackets. So ky minus kx equals y plus x. And now in order to solve this equation we need to get all the y's onto one side of the equation. So to do this we can add k plus x to both sides, which gives us ky is equal to y plus x plus kx. And finally we want to minus y from both sides. So ky minus y is equal to x plus kx. So as we can see, we now have two y terms on the left hand side of this equation. So what we can do is we can factorise this by taking out y. So if we divide ky by y, this gives us k, and if we divide negative y by y, this gives us minus 1. And then we can do the same on the other side of this equation. So kx divided by x gives us k, and then x divided by x gives us plus 1. And now the final thing we need to do is get y alone on one side, and we can do this by dividing by k minus 1. And this shows us that y is equal to x brackets k plus 1 divided by k minus 1. And our second mark comes from writing this equation here, and the third mark for using the correct algebraic reasoning to prove that this is correct. X equals 0.436 reoccurring. Prove algebraically that x can be written as 24 over 55. So the first thing we want to do is rewrite this number but to more decimal places. So this means that x is equal to 0.43636 and so on. Now this is because the dots are above the 3 and the 6, so we'll repeat the 3 and the 6 infinitely. Now in order to prove algebraically that x can be written as this fraction here, we want to find two coefficients of x which have identical numbers after the decimal place, so that we can minus these two numbers from each other. So in order to do this we can multiply both sides of this equation by 10. So 10x is equal to 4.363636 and so on. Now as we can see, we haven't got two numbers which are identical after this decimal point, so we're going to continue multiplying these by 10. So 100x is equal to 43.636363 and so on. And again, we don't have two numbers which we can minus from each other, so again we'll multiply this number by 10. So 1000x is equal to 436.363636 and so on. Now what we can see is 10x and 1000x both have 0.3636 and so on after the decimal point. Now we get our first mark for writing one of these values. And as we can see, we've now got two numbers which we can minus from each other, which is this 1000x here and the 10x up here, as they both end in 0.3636 and so on. So what we can write is 1000x minus 10x is equal to 436.36 reoccurring minus 4.36 reoccurring. Now this will give us a whole number, meaning we can rewrite it as a fraction. And we'll get our second mark for identifying two numbers which we can minus from each other to give a whole number. So the next thing we'll want to do is we'll want to simplify this down. So 1000x minus 10x gives us 990x. And then 436.36 reoccurring minus 4.36 reoccurring will give us 432. Because this 0.36 will cancel out. Next we'll want to rearrange this equation to make x a subject. So we can divide both sides by 990, and this tells us that x is equal to 432 divided by 990. So the final thing we need to do to prove that x can be written as 24 over 55 is show that this fraction can be rewritten as 24 over 55. So 432 over 990, well if we divide both the top and the bottom by 2, this gives us 216 over 495. Now what we can do is divide both the top and bottom by 9, which gives us 24 over 55. So we can therefore write that x is equal to 24 over 55. And we'll get our final mark for writing this. Y is directly proportional to the cube root of x. Y equals 1 1/6 when x equals 8. Find the value of y when x equals 64. So y is directly proportional to the cube root of x. Now what this means is when we increase the value of y, the value of the cube root of x will also be increased. So we can rewrite this as y is equal to k multiplied by the cube root of x. So in order to work out this question, we need to work out the value of k. Now to do this, we can substitute the values for y and x that we've been given in the question into this equation. So our value for y we've been given is 1 1/6, which we can rewrite as 7 over 6. So 7 over 6 is equal to k multiplied by the cube root of 8, which is the value we've been given for x. So the next thing we need to do is we need to simplify this equation to make k the subject. So the first thing we can do is we can get rid of this surd here. So the cube root of 8 is equal to 2. And this is because 2 multiplied by 2 multiplied by 2 gives us 8. So we can rewrite this equation as k multiplied by 2. And now the final thing we need to do is we need to divide both sides of this equation by 2. And this will make k the subject of this equation. So 7 over 6 divided by 2 will give us 7 over 12 because we multiply the denominator of the fraction by 2. And then k multiplied by 2 divided by 2 will give us k. So now what we need to do to finish off this question is we need to substitute our value for k that we've worked out and the second value for x that we've been given in the question into this original equation which we formed to work out the value of y. So when x equals 64, y is equal to 7 over 12 multiplied by the cube root of 64. So again, we can simplify the cube root of 64 down. So the cube root of 64 is equal to 4. And again, this is because 4 multiplied by 4 multiplied by 4 gives us 64. So we can simplify down the right-hand side of this equation. And 7 over 12 multiplied by 4 is 28 over 12. And finally we need to simplify down this fraction, and we can do this by dividing both the numerator and the denominator by 4. and this tells us that y is equal to 7 over 3. Now this question is worth 3 marks, and we get our first mark for writing this equation, we get our second mark for working out the value of k, and then our third mark for the correct answer. N is an integer. Prove algebraically that the sum of half n brackets n plus 1 and half brackets n plus 1 multiplied by n plus 2 is always a square number. So the sum of two numbers is when we add together the numbers. So we want to prove that half n brackets n plus 1 plus a half n plus 1 brackets n plus 2 is always a square number. So in order to do this, we'll want to expand out these brackets. So if we start off with this first number here, a half n multiplied by n gives us a half n squared, and then half n multiplied by 1 gives us half n. And now if we move on to this second number here, we can first start off by expanding out these brackets here. So it can sometimes be helpful to add arrows when we're multiplying out two brackets so that we can see this clearly. So n multiplied by n gives us n squared. N multiplied by 2 gives us 2n. 1 multiplied by n just gives us n. And then 1 multiplied by 2 gives us 2. And we can again simplify this down. And finally, we'll want to multiply all these three numbers by a half. Now we can add together the like terms. So we have n squared, n, and then the numbers. So if we start off with the n squared terms, a half n squared add a half n squared will just give us n squared. Next, a half n plus 3 over 2n will give us 2n. And finally, there's only one number, so we can write plus 1. So now the final thing we'll need to do is we'll need to factorise this here so that we can prove that it will always be a square number. So in order to factorise this, we'll need to find two numbers which will add together to make 2 and multiply together to make 1. So 1 and 1 will add to make 2 and multiply to make 1. So we can rewrite n squared plus 2n plus 1 as n plus 1 multiplied by n plus 1, which we can again rewrite as n plus 1 squared. Now as we can see, n plus 1 squared will always be a square number because it's got this squared here. And we can substitute any value into n and it will still give us a square number. So the final thing we need to do is write a summary statement. So we can write something like, therefore, the sum of these numbers will always be a square number because a half n brackets n plus 1 plus a half brackets n plus 1 brackets n plus 2 is equal to n plus 1 squared. Now this question is worth 2 marks and we'll get our first mark for expanding out these brackets here for both of the numbers, and the second mark will come from completing the proof with an explanation and reference to this n plus 1 squared. Enlarge shape P by a scale factor of -1/2 with centre of enlargement 0, 0. Label your image Q. So in order to work out this question, we want to work out the coordinates of each of these three vertices of the triangle and then multiply each coordinate by -1/2. So we can start off by labelling these coordinates. So point A, as we can see, we go 2 along and then 7 up. So the coordinate is 2, 7. Next, point B, again we're going 2 along, but only 3 up this time. And then finally, coordinate C, we're going 4 along and then 3 up. So now what we need to do is multiply each of these numbers by negative a half. So if we start off with coordinate A, which is 2, 7, if we multiply each of these coordinates by negative a half, so negative a half multiplied by 2 gives us negative 1, and then negative a half multiplied by 7 gives us negative 3.5. So we can mark in point A as negative 1, negative 3.5. Next we can move on to coordinate B, which is 2, 3. And again we'll multiply both of these coordinates by negative a half, which will give us negative 1 and then negative 1.5. And then finally coordinate C, so 4, 3, so 4 multiplied by negative a half will give us negative 2, and then negative a half multiplied by 3 gives us negative 1.5. And now the final thing we need to do is connect these dots to create a triangle. And label the image Q. So as you can see, shape Q is still a right-angled triangle, but it's half the size and has been rotated 180 degrees. And we get our 2 marks for drawing the correct shape with the correct coordinates. ABCD is a rectangle. A, E and B are points on the straight line L with equation x plus 2y equals 12. A and D are points on the straight line M. AE equals EB. Find an equation for M. So what we can start off with is we can annotate this diagram. So ABCD is a rectangle. So each of these vertices A, B, C and D, we can label them up as right angles. The next piece of information we have is that AE is equal to EB. So again we can mark these on. So we've been given the equation for the straight line L, however it's not in the correct form, which is y equals mx plus c. So we can rearrange this equation to make y the subject. So we can first minus x from both sides, which gives us 2y is equal to negative x plus 12. And then we can divide both sides by 2. And this gives us y is equal to negative a half x plus 6. And we get 1 mark for writing the correct equation. Now what this tells us about line L is that the gradient of it is negative a half and the y-intercept is 6. So we can mark on that point E is 6, as this is the y-intercept. So as we can see, line L and line M are perpendicular to each other because of this right angle. Now when two lines are perpendicular to each other, their gradients multiply to make negative 1. So what this tells us is that negative a half multiplied by the gradient of M is equal to negative 1. And we can rearrange this by dividing both sides by negative a half, which tells us that the gradient of line M is 2. So we can start substituting this into an equation. So this will tell us that y is equal to 2x plus c. Now we'll get a second mark for working out the gradient, and in order to work out the y-intercept and therefore the full equation, we need 2 values which we can substitute into this. So if we take a look back at the diagram again, we'll be able to work out the coordinates of point A. So in order to do this, the first thing we can do is we can work out what this point B is here, which is the x-intercept of line L. So we can substitute the value y equals 0 into this equation, and this tells us that 0 is equal to negative a half x plus 6. We can add negative a half x to both sides, and this tells us that half x is equal to 6, And now finally divide both sides by half, and this tells us that x is equal to 12. So we can add this to our diagram. Now line AE is equal to EB, and in order to get from point B to point E, we've had to minus 12 from the x-coordinate and add 6 to the y-coordinate. So we can use the same calculation to get from E to A. So if we're starting off with the coordinate 0, 6, we'll first minus 12 from the x-coordinate, and then we'll add 6 to the y-coordinate. And this tells us that point A is negative 12, 12. Now point A lies on the line M, so we can substitute these values back into our equation. So y is equal to 2 multiplied by negative 12 plus c. So we can first start off by expanding out these brackets, and this gives us 12 is equal to negative 24 plus c. And again we'll need to get c on its own on one side, so we can add 24 to both sides, and this tells us that the y-intercept is 36. And we can now substitute this again back into the equation. And this tells us that the equation of line M is y equals 2x plus 36. And we'll get our final 2 marks for using the correct workings to reach an answer. The table shows some values of x and y that satisfy the equation y equals a cos x plus b. Find the value of y when x equals 45. So in order to work out this question, we're going to want to substitute 2 sets of values for x and y from this table into this equation to work out the value of a and b. So the equation contains cos x, so we can choose 2 values for x which will not include surds to make the question easier to work out. So we can choose the value x equals 0, and we can choose the value x equals 90. So now what we need to do is we need to substitute both of these values for x and y into this equation. So we can start off with the value x equals 0 and y equals 3. So our value for y is 3, and this is equal to a multiplied by cos 0 plus b. Now for the exam you're expected to know the value for cos 0, and cos 0 is equal to 1. So 3 is equal to a multiplied by 1 plus b, which we can simplify down to 3 is equal to a plus b. Now we can do the same for the values x equals 90 and y equals 1. So 1 will be equal to a multiplied by cos 90 plus b. And again you're expected to know the value for cos 90 for the exam, and the value for cos 90 is 0. So 1 is equal to a multiplied by 0 plus b. And a multiplied by 0 is 0. So we can work out that b is equal to 1. So what we can do now is we can substitute the value that we worked out for b into the equation 3 equals a plus b. And this tells us that 3 is equal to a plus 1. And we can minus 1 from both sides. And this tells us that a is equal to 2. So the next thing we need to do is we need to substitute the values for a and b which we've worked out, and the value for x which we've been given in the question, into the equation above to work out the value of y. So we can write that y is equal to 2 multiplied by cos 45 plus 1. Now cos 45 is another trigonometric ratio which we're expected to learn for the exam, and the value for cos 45 is root 2 over 2. So we can write that y is equal to 2 multiplied by root 2 over 2 plus 1. So 2 multiplied by root 2 over 2 will just give us root 2. And then we have the plus 1. And we can't simplify this down anymore. So we've worked out that y is equal to root 2 plus 1 when x is equal to 45. So this question is worth 4 marks. And we'll get 1 mark for substituting in a value for a known trigonometric ratio, a second mark for forming our two equations with a and b, a third mark for working out the values of both a and b, and then the fourth mark for working out the correct answer. Show that 6 minus root 8 divided by root 2 minus 1 can be written in the form a plus b root 2, where a and b are integers. So in order to complete this question, we need to get rid of this surd on the denominator of the fraction. This is called rationalising the denominator. So we're going to multiply it by root 2 plus 1 divided by root 2 plus 1. So by multiplying the fraction by root 2 plus 1 divided by root 2 plus 1, this is the equivalent of multiplying the fraction by 1. However, it's going to get rid of the surd on the denominator of the fraction and therefore make this number a rational number. So the next thing we'll need to do is simplify down this expression. So when multiplying two fractions, we multiply the numerators together and we multiply the denominators together. Now next we'll need to expand out these brackets. Now this may look complicated at first, however it's the same as multiplying out brackets with an x term in, just using surds instead. So first we'll start off by multiplying 6 by root 2, which will give us 6 root 2. 6 multiplied by 1 will give us 6. Negative root 8 multiplied by root 2 will give us negative root 8 multiplied by 2. And then finally negative root 8 multiplied by 1 will give us negative root 8. And now we'll do the same for the denominator of this fraction. So root 2 multiplied by root 2 will give us 2. Root 2 multiplied by 1 will give us plus root 2. Negative 1 multiplied by root 2 will give us negative root 2. And then negative 1 multiplied by 1 will give us negative 1. Now our first mark comes from multiplying these two fractions. The next thing we'll need to do is simplify this fraction down. So we can start off with the numerator. So the first thing we can simplify down is this negative root 8 multiplied by 2. And this gives us 6 root 2 plus 6 minus root 16 minus root 8. Now 16 is a square number, meaning when we square root it, it will give us a whole number. And the square root of 16 is 4. So we can now minus this 4 from 6. Now as we can see, we still have 2 surds in this number. However, we want our answer with just 1 surd in, which is root 2. So we can expand this negative root 8 into root 2 multiplied by 2 multiplied by 2, which we can again rewrite as root 2 multiplied by root 2 multiplied by root 2. Now again we can treat this the same as algebra, and we can rewrite this as 3 root 2. And now what we can do is we can minus 3 root 2 from 6 root 2. And this gives us 3 root 2 plus 2. Now we get our second mark for the expansion of this numerator. And now the final thing we need to deal with is this denominator. So the first thing we can do is we can cancel out this root 2 because we've got root 2 minus root 2. And this will give us 0. So this leaves us with 2 minus 1, which will just give us 1. So we can rewrite this fraction as 3 root 2 plus 2 divided by 1. And again, so that it's in the correct form that we want for the answer, we can rewrite this as 2 plus 3 root 2. And this is where our third mark comes from for showing that this fraction can be rewritten in this form where a and b are integers. The two triangles in the diagram are similar. There are two possible values of x. Work out each of these values. State any assumptions you make in your workings. So the first thing we can do for this question is we can highlight the key pieces of information. So these two triangles in the diagram are similar. Now what this means is this smaller triangle is proportional to this larger triangle. And the second thing to note for this question is there are two possible values of x. Now the reason for this is because side AE may be proportional to side AD. However, side AE could also be proportional to side AC. So we want to work out the possible values of x for both of these scenarios. So we can start off by letting k be the scale factor of these triangles. So what we can write is that side AE multiplied by k is equal to side AD. However, if side AE is proportional to AC, then we can also write that AE multiplied by k is equal to AC. So what we can do from the equation we formed on the left is substitute the values from this diagram into this equation. So side AE is equal to 12 and side AD is equal to 12 plus 3, which is 15. So now in order to work out the scale factor, we're going to want to make k the subject, and we can do this by dividing both sides by 12. And we can simplify this down to 5 over 4. So if side AE is proportional to side AD, then what this means is that side AB will be proportional to side AC. So we can form a new equation from this. And again, we can substitute the values from the diagram into this equation, but also the value for k which we've worked out. So side AB is equal to 8. Our value for k which we worked out is 5 over 4. And side AC is equal to 8 plus x. Now in order to work out a value for x, we want to rearrange this equation to make x a subject. So we can first start off with the left-hand side of this equation. 8 multiplied by 5 over 4 can be rewritten as 40 over 4. And this is all equal to 8 plus x. And 40 divided by 4 is equal to 10. And then we can minus 8 from both sides, and this tells us that x is equal to 2. So this is one value for x. Now we can use the same method to work out our other value of x. So with the knowledge that side AE is proportional to side AC, we can also work out that side AB multiplied by k will be equal to AD. And we're going to want to substitute the values from this diagram into this equation. So side AB is equal to 8. We don't know our value for k. And side AD is equal to 12 plus 3, which is 15. And again, we're going to want to make k the subject. So we can divide both sides by 8, and this tells us that k is equal to 15 divided by 8. Now in order to work out our second value for x, we can substitute our value of k into this first equation we formed here. So side AE is equal to 12. Our value for k is equal to 15 over 8. And our value for AC is equal to 8 plus x. So again, we're going to want to rearrange this equation to make x a subject. So 12 multiplied by 15 divided by 8 is the same as writing 12 multiplied by 15 all over 8. So 12 multiplied by 15 is 180. And what we're going to want to do is simplify down this fraction on the left-hand side of the equation. So we can rewrite 180 divided by 8 as 90 over 4. And again, we can rewrite this as 45 over 2. And 45 divided by 2 is 22.5. And now the final thing we want to do is make x a subject, so we can minus 8 from both sides. And this tells us our second value of x is 14.5. So now the final thing we need to do for this question is state any assumptions which we've made. So in our first scenario, where AE is equal to AD, we've assumed that angle AEB is equal to angle ADC. Now in our second scenario, where side AE is proportional to side AC, we've assumed that angle AEB is equal to angle CAD. Now this question is worth 5 marks, and the 5 marks come from stating our assumptions, for working out one of the scale factors, and using a suitable method to work out the other scale factor, and our final 2 marks for working out the correct values for x. Here is a rectangle and a right-angled triangle. All measurements are in centimetres. The area of the rectangle is greater than the area of the triangle. Find the set of possible values of x. So the first thing we'll need to know for this question is the formula for the area of a rectangle and the area of a triangle. So the area of a rectangle is base multiplied by height, and the area of a triangle is half multiplied by base multiplied by height. So we've been told that the area of the rectangle is greater than the area of the triangle. So what we can start this question off by doing is working out what the area of the rectangle and the area of the triangle is. So if we start off with the rectangle, so the formula is our base multiplied by our height. So the length of our base is 3x minus 2, and the length of our height is x minus 1. So we can substitute these values into this formula. And this means that the area of our rectangle will be 3x minus 2 multiplied by x minus 1. Next we can work out the area of the triangle. So our formula is half multiplied by base multiplied by height, and the length of our base is x, and the length of our height is 2x. So this means the area of the triangle will be a half multiplied by x multiplied by 2x. And we can simplify this down to a half multiplied by 2x squared, which we can again simplify down to just x squared. Now the next thing we need to do is we need to form an inequality for these two areas. So we can write that 3x minus 2 multiplied by x minus 1 is greater than x squared. So we'll first start off by multiplying 3x by x, which will give us 3x squared. 3x multiplied by negative 1 will give us negative 3x. Negative 2 multiplied by x will give us negative 2x. And then negative 2 multiplied by negative 1 will give us positive 2. And this is all greater than x squared. Now we can again simplify down the left-hand side of this inequality, and we can rewrite this as 3x squared minus 5x plus 2 is greater than x squared. And the final thing we'll need to do is make this inequality equal to 0. so that we can solve the inequality. So we can finally minus x squared from both sides. And now what we've been left with is a quadratic, which we can solve. Now there's a few different ways which you can solve this quadratic. However, I've decided to factorise it. So in order to factorise it, we want to multiply the coefficient of the x squared term by the constant. And this tells us that we need two numbers which will multiply together to give us 4. And then we'll take this middle number here, the x term, and this tells us that we need two numbers which will add together to make -5. And two numbers which will fit this criteria are -1 and -4. So we can rewrite this inequality as 2x squared minus 4x minus x plus 2 is greater than 0. Now what we can do is we can factorise both the left and right hand side of this line. So if we start off with the left, we have 2x squared minus 4x, so we can take out a 2x, and this will all be multiplied by x minus 2. And the same with the right hand side, we have negative x plus 2. And we can factorise this as -1 multiplied by x minus 2 is greater than 0. And now finally we'll place this 2x and -1 into its own bracket. And this gives us a fully factorised quadratic. So what we can learn from this inequality is that our two critical values for x will be 1/2 and x is equal to 2. Now what this means is when x is greater than 1/2 and when x is greater than 2, then this inequality is correct. However, if we choose a value between 1/2 and 2, then this will satisfy the inequality x is greater than 1/2, but it won't satisfy the inequality that x is greater than 2. So we can just choose this x is greater than 2 value. So our final answer is x is greater than 2. Now this question is worth 5 marks. We get 1 mark for working out both the area of the rectangle and the triangle. We get a second mark for rearranging this inequality to make it greater than 0. We get a third mark for using a suitable method to solve the quadratic. We'll get a fourth mark for working out the two critical values, and our final mark for the correct answer.